Hello, everyone. I am Jez San, one of the founders. Hey, Tom. One of the founders of Funfair. My colleague Jeremy is also one of the founders.
Hi there.
Hey. And we are going to give you an update on Funfair and tell you what we've been up to. So, oh, my slides didn't work. Right, we'll go manual. So Funfair is a gaming platform that runs on the blockchain, on Ethereum, and it powers adult gaming for adults, which is casino games. We support a wide variety of a wide variety of titles. The games run in real time at commercial quality performance. The game sessions are started on-chain and then run completely off-chain using our own version of state channels that we call fate channels. So to give you a little clue as to what we do, this is one of our marketing show reels. Don't worry, it's very brief, but it'll give you an idea. There we go. So that's, to summarize, the kind of games that we do. They look and feel and play like all online casino games, except that we're using the blockchain. So our goal is to maintain the high standards that commercial gaming provides, but do it in a way that is more fair for the player. So, for instance, it is fully trustless and non-custodial. That means that the player actually plays the games from their own wallet, and if they win something, it comes back to their own wallet. In a traditional online casino game, the player normally has to make a deposit into the custody of the casino before they can play any games, and then if they make any wins, they actually have to request a withdrawal from the casino, and that's where the problems start, because the casino might have any number of reasons to not allow that withdrawal. They might have KYC requirements, or they might actually be trying to upsell the player onto other products before they can get their money back, or there might be, or it might be a scammy casino, and they might be trying to actually exit scam the player. So being able to play in a trustless and non-custodial way is actually a big deal. The games are provably fair and guaranteed cheat-proof, and we'll be able to explain a little bit more about how that happens. We use state channels not only to solve the scaling issues and allow the games to run fast, but also to guarantee that they obey the rules of the game and make sure that no one can cheat. The ecosystem has been designed to support all of the existing community that is required in the casino industry. So we support casinos themselves, who are a brand, and they do marketing to recruit players. We also support independent game developers who will produce games that can be put on the platform. And we support affiliates who are the lifeblood of the marketing in the casino gaming industry. And all of this is designed to cooperate in the ecosystem, and all of it is settled in real time on the blockchain, so it's trustless and transparent. We also have a universal KYC system that we call FunPass that allows players to do the KYC once, and effectively receive approval to play on any casino that supports the system. And it could be extended one day to support a vulnerable player database, which is where a player might have decided that they don't want to play anymore and they want to be restricted from playing, and they actually voluntarily say, please exclude me, and we need to help them make sure that if they hop from casino to casino, that they can't find an outlet and be able to play if they didn't want to. So the same system would help us with both. So the games are complete applications in their own right. The game is in two parts. It's in the UI that is presented to the user. You saw in the video what games might look like. And that is the graphics, the audio, the actual look and feel of the game is done in browser. And then there's also a back end to the game, which is built with smart contracts written in Solidity. And those contain the game rules, and for every game, whether it's roulette or blackjack or baccarat, the game rules will be different, and so these are all separate smart contracts. And in some cases, some games have multiple smart contracts because the game is more sophisticated than can fit in one. So when a player starts a game session, they click to play the game. It's all very user-friendly. At that time, the Fate channel is actually opened, and deposits from the player and the casino are brought onto the chain, together with the seeding of the random numbers, which is done by both the player and the casino. It also specifies at the time which game smart contract is going to be executed at the time of opening the channel. This allows the accounting to be done correctly on-chain for what game developers are owed when the game is done, because the game developers get a share of the revenue. And so it's important that the actual revenue is tracked correctly on-chain for full transparency and to make sure that there's no collusion. When the player has finished the game and they've quit or they're done, the session ends. But it also would end if a dispute was raised, and if either the player or the casino decided that something had gone amiss, which could have been cheating or it could have been a bug or some kind of error, then there's an on-chain dispute resolution phase, and that's when the Fate channel closes. Our state channels are somewhat generalized in that they aren't just payment channels. Payment channels have been done before with the Lightning Network and with Raiden, and even SpankChain is using payment channels with their Connect system. The difference with general state channels is that they actually execute code. They actually run the smart contracts off-chain. And so there's a very good scaling benefit in doing that, and a massive reduction in gas cost. And so it's what enables us to do responsive, interactive games at a speed and a playability that people are used to and that people demand. But it's also very good for protecting the security of the games to ensure that they're fair. And so my colleague, Jeremy, is going to talk you through a bit more detail about how the state channels work.
Okay, hi everyone. So obviously there's a lot of moving parts to our product as a whole, but it is underpinned by this concept of state channels. Hopefully, at least most of you have heard of them. It's one of the layer 2 solutions being worked on top of Ethereum. And so there are quite a few of us doing our own implementations at the moment, and we've built our own bespoke one of those, and we're very much hoping that there's going to start to be a lot more collaboration between those guys working on state channels so that we can get some sorts of standards in. But until that happens, just talk you through a little bit about the specific implementation that we've done. So we have a two-party bidirectional channel, and it has fully generic state machine support. So fundamentally, you can execute any code that you can write in a Solidity smart contract, as long as it's able to be executed on the chain if it needs to be. In addition to that, we've integrated the random number generation into the state channel. It's a generalized form of a commit reveal scheme. It provides one 256-bit seed per state transition. And it's deterministic but unpredictable, which is why I slightly cheekily called this thing a fate channel, as in it is determined in advance, but you don't know what it's going to be. It's optimized for our initial use case, which is casino games. You open, as Jez has mentioned, you open one channel for one game session. The state advances with an action from both players at the same time, which is a bit unconventional. So it's not like chess where one player moves and then the other player moves. The player and the casino act in coordination to generate both the random number and the outcome of the game. It's a bit more like rock, paper, scissors. And this makes the coding of the actual games themselves pretty straightforward, but it makes dispute resolution slightly harder. I'm just going to chat a little bit about dispute. It's a fundamental part of a state channel. When everything's going swimmingly, it's very easy and very straightforward. Approximately 80% of the code involved in writing a state channel is to do with what happens when it goes wrong. So we can talk about this in detail, but broadly speaking, a dispute is essentially what happens when one party doesn't follow the protocol. So it's important to understand that a state channel is a protocol. It's a series of rules that each party needs to follow off-chain to be able to advance the state and to continue the execution of the game in a fair and a pre-agreed manner. So if you reduce everything that can go wrong, from network timeouts to laptop blowing up to someone trying to be malicious to a single statement that one of the parties is not following the protocol, then you can condense all of these cases into a single state where you make a claim, well, the initiator of the dispute makes a claim on-chain saying the other party is not doing what they should be doing. And so the disputer advances, if they need to, from the previous state to the current state on-chain using the smart contract. And that places the channel into dispute. And then if it's valid, and then the other party has got to do something, and they've got a few options that they can do. They can provide the next state transition, as in they can work out what it is off-chain and send that to the smart contract that's governing the state channel. This is validated on-chain, and if it's correct, and they provided their signature to it, it has a magic property that means that the channel can continue off-chain. So you've had a dispute, you've agreed something's wrong, you've used the chain to interact with the smart contracts, and you've resolved that dispute, and now you can carry on with the state channel. And that's a really clean way of making these things actually work, especially in cases of network timeout and sort of unmalicious activity. There are a couple of other things you can do. You can claim no dispute if you're happy with it and you just want to get out of the channel. You can just end it there and then. If you do nothing, if you've gone on holiday and left your laptop at home, we've got to resolve this thing one way or the other. So the channel can time out, and the person that raised the dispute can claim a timeout to end the channel. And you can do a couple of, there's actually two of these, but you can challenge with a later state. So if I'm losing and I say, well, there's a dispute, and I post state 4, but I've actually signed state 8 where I was losing, then if the counterparty can present state 8 to the channel contract, then we know that someone's trying to cheat, so that player is penalised. That's a very, very quick introduction to that. Just to give you some stats, these numbers. Okay, let's just see what we've got here, as I didn't put these numbers in the spreadsheet. So we've had a few thousand state channels correctly opened and closed. We've had nearly 1 million off-state transitions actually happen in our system. Because these are short-lived channels, we're averaging about 250 state transitions per channel. That's a few spins of a slot machine. We'll play games of blackjack or that or so other. We've actually had a game recently that ran for nearly 10,000 state transitions. I haven't worked those numbers out, but from October we had one that did 5,000. We worked out it would cost 1.5 billion gas to run on the chain, about $2,500 to run this on the chain. But using state channels, a layer 2 solution with all of the security features of the Ethereum layer 1 blockchain, costs 60 cents. So we're pretty happy that we've proved that the state channels as a concept actually works. Yeah, we're pretty happy with it. It's stable and it works. And we've had a few cases of dispute resolution. We've had some that have resolved and gone back off chain, which is great. We've had some that have been triggered by bugs in our software, and we were penalised, which is unfortunate, but is exactly the way that it works. If the casino's got a problem, the player playing that game actually got rewarded for finding that bug, and so that they knew that their money was safe the whole time. I think that's my slides. No, we've got, what have we said here? So yeah, I mean, this is a summary of an earlier talk that I gave, but building customer-facing dApps is hard. State channels make it harder still. We have a whole load of automated systems that interact directly with the blockchain, and that's even harder. I can talk to you about uncles for about an hour anytime anyone wants, but we're live and we've got a lot more stuff in the pipeline. Jez.
Thanks, Jeremy. So the first casino that went live is called Casino Fair, and it's actually a pilot casino that we launched ourselves. We really wanted to gather data, and we wanted to learn from real customers, and we have actually learned a lot. The casino is currently live in 22 jurisdictions. That we're quite conservative, and we've launched in the places that the lawyers have told us are the safest places to launch. There will be more countries in the future, and there will be more gaming licenses that allow us to do that in more. Currently, we have 13 games that we built ourselves. Actually, 12 that we built ourselves, and one that a third party built that are all live, and you can play them today on the showcase at funfair.io if you're not in one of the countries where you're allowed to play for real money. So we discovered after we launched in September that onboarding is a big issue. It's something that everyone's talking about, and the real problem is that new users have a lot of difficulty creating accounts, getting on the blockchain, buying crypto, converting crypto from one token to another, and so on. So there turns out there's quite a lot of friction in onboarding new users, and we learned this firsthand, and then we put instrumentation in our site so that we could gather the analytics to figure out where people are getting stuck. And we can see a few pain points where there's a lot of friction, and so we've dedicated the project and the team to resolving this onboarding friction, and the last few months and the next few months are certainly going to be very busy improving the onboarding and reducing friction. So it really is actually quite painful for a new user to create an account, to give an example of the kind of pain points, there's if they arrive on the wrong device, or they have the wrong browser, or they have the wrong wallet, then all we can do is tell them, go download this wallet, or go download that browser. And that isn't a good user experience when a customer or potential customer arrives on the site, and the first thing they see is, oh, you're using the wrong browser, go download this one, or whatever. It's just not what we want to tell potential customers. So we vowed that we would fix that, and it was an area that we never intended to have to address. We thought we would build a great DApp and solve a problem for the casino industry, and that the users would use it. But it turns out that there's friction outside of our control in the wallets and the browsers and device support. So we've actually spent a lot of effort on doing stuff that we never intended to do. So the first one is wallets. Wallets are actually the present wallets, although they're good, they're only really good if you know what you're doing and if you happen to have the device that they run on. So for instance, I love MetaMask, but MetaMask only really runs on Chrome and Chrome-alikes, doesn't run on Safari, doesn't run on mobile yet. Even if it does, it's going to be another app, and getting users to go download a new app when they're not using the one that works isn't a good user experience. In fact, I think if you tell people you need this app or that app, they're not going to get it. People have a resistance to downloading new apps that you tell them to download. So users also have trouble creating accounts or backing up seed phrases, or even worse, if they lose their seed phrase or they have some kind of, they lost their device that their wallet's on. So all of these problems are what stop new users from being onboarded into our dApps. And so we thought that we should actually address that and build our own wallet. I know there's a million other wallets in development, but many of them haven't solved the right problem yet, or are working on it, but it's just not live yet. And we didn't want to let our fate be in other people's hands, so we thought that we needed a wallet that would be easy to use for a new user, that wouldn't make them write down a 24-word seed phrase, that would be easy to recover if they lost their account, and so on. This is actually a visualization of what it's going to look like. It is actually in development, and it does kind of work, but it doesn't look as good as this yet, and obviously we've got a few months to go on the development of it. Another area that was a big problem is mobile support. it turns out that 60 or 70% of the potential customers use mobiles and not desktops, and yet mobile support for Ethereum dApps is very poor, and even the wallets that do exist on mobile don't interact with dApps correctly. And so you might be able to transfer tokens around, or you might be able to buy crypto, but you can't actually interact with dApps directly from the wallet. So we've also spent a lot of time now optimizing our games to look good on mobile, because even though they might have run before, they were desktop apps, the buttons were a certain size, the text and the graphics was a certain size, so we had to actually rebuild everything again to look good on mobile. So with the wallet and the mobile optimizations, we think we can actually reach the customers that we've had a problem with before. So in the past, we've built our own games. The first 12 games were built directly in-house, and although that's more than any other blockchain casino, it's not enough. In the real world, casinos have tens or even hundreds, sometimes even thousands of games. So we needed to enable our platform to be able to support third-party game development, to allow anyone that has existing games or anyone that wants to build new games to be able to put them on our platform and run on the blockchain. And usually, if it's an existing game, the game has been built to, in a client-server way, so it's been built to access a remote gaming server, or RGS as the industry calls it. And that needs to be rebuilt into a smart contract to be the back end of the game. We have a bunch of games that we're working on, and I'll give you a preview shortly in a minute. This is something we are working on. It's quite early days, but it's a virtual horse race game. And now I'm going to show you a video preview of something that we haven't shown before. This is some of the games we have coming very soon. Oops, that did not work. We've got sound again now. So the Alice Cooper game was actually built by a third party called Spike Games. So most of those games are in quite late development, and they'll be coming very soon. Just to summarize where we are, we launched the showcase, the early prototype of our games and our state channels in June 2017. We launched the first commercial state channels on mainnet in middle of 2018, approximately. The first casino was launched in September 2018, and that's Casino Fair. As I mentioned, we've got 13 games, mostly first-party games, and just the third-party games are starting to come online. And you saw we've got several games in development to come out shortly, and that we're now focusing on onboarding and reducing friction and making sure that anyone that wants to play these games can actually access and play them. And that does mean making it easy to use and running on every device and every browser. So in the short-term future, we've been working on a new version of the Fate channels, and we plan to open source that in the near future. we also will be launching new casinos. The technology and the platform has been built to support multiple casinos, and there will be multiple this year. And our goal is to keep trying to innovate and show the casino gaming industry that the player could have a better deal and that fairness and safety could be put first. And the technology that we've built provides that, and is also actually less expensive for casinos to operate than the server-based systems they operate today. So thank you very much, and do please let me know if you have any questions.
So I think I remember you said that you have one-on-one channels, so there's 2 participants. So obviously one guy always watches the other one, right?
Yeah.
Are you guys planning to extend this to a multi-participant setup? And if so, do you have a design for a watchtower that can kind of be trusted or delegated to?
So I think there's kind of 2 questions there actually. I mean, on the second one, in terms of watchtowers, I mean, watchtowers in terms of state channels are very much they're not separate. They're a parallel research project, right? I mean, I think there's a lot of work going on with that. I know Patrick, who's supposed to be around here, is doing a lot of work on it with PISA, but many other people obviously working on it as well. It's a parallel thing. I don't think we're going to spend a lot of time on it right now. If it needs to be a solution, I think we could run a thread on that as well, but I'm just watching what other people are doing. Certainly in terms of the way that we're doing our state transitions, everything is continually co-signed, and you certainly could delegate that responsibility to a third party at any point. You just need to come up with a good, sensible economic model for watchtowers to decentralize that process. I mean, it'd be trivial to build a centralized watchtower to just help the user out, and they might commit to that. But I think we're all looking for a solution that involves decentralization when it comes to watchtower solutions. Yeah, I mean, we do have short-lived channels, so to some extent it's less of a problem, but it's still potentially a problem. As to your first question on multi-participant channels, for us it's a big step up from what we've currently done. So if you in the context of this, it would be something like, I know, Hold'em poker, right? Traditional multiplayer poker. I think what we've really tried to do is to focus on one thing and get it right. One of the big drivers of this business was get something out there, launched live, commercial grade, working, not just a proof of concept, not just a white paper. This is an actual product, and we know we can do this now. We're very interested in looking into that in the future.
Hey. So maybe it's like a follow-up to that exact sort of answer. I know that the games you guys have showed now and that Casino Fear have developed is sort of like the random numbers-based gaming. Are you guys looking in the future to sort of move that out a little bit, out of just like spinning a dice basically and having that insured dice spinning?
So, I mean, I think, again, it's the same, almost the same answer, right? And so we've got to focus on one thing and get one thing and do it right. And that's really what we've chosen to do. Having said that, the state channel solution, the version 1 that's live right now, is very focused on exactly that. And it's the project that I'm working on right now, is chopping that up into nice bits so that we can use large components of what we've built that don't rely on RNG, particularly the RNG implementation, or the way in which we do a turn-based system. And so, I mean, that works, he says, nearly done, fingers crossed. And then that would give us as a company the opportunity to explore into new areas. But from a marketing and setup point of view, we're very much aiming at casino gaming right now.
I should just add that many games involve random numbers. It's not just casino games. You know, probably almost every game that has launched on Ethereum to date has some randomness in it, even crypto kitties. So this is, randomness is still very important. But obviously, skill games are another kind of game. Great. Thank you so much.